Hello, everybody again. Hope you all had a good weekend. So plan for today, on Thursday, if you recall, we had a introduction to algorithms. So, we did have a smaller class, but I do encourage the folks that weren't able to attend to view that class online. We started working on an exercise, take-home exercise, and to kind of start practicing the first algorithm that we went over, which is the binary search algorithm. All right, so very, very important algorithm in computer science, and used in practice and in interviews and all of that stuff. So I posted the homework, or at least material for thought, in the Slack. And that's really all about implementing the algorithm in code. So basically using, just function for now. On Thursday, we will look into something called recursion to solve such an algorithm. But for now, I want you to start thinking about how you would implement this algorithm in code, and we will finish that work on Thursday, and I'll look into the recursion. So again, look at the Thursday class and check out the the assignment in the CodeWell channel. Any questions on that? From anybody that attended the class or possibly started the work? Not yet. Okay. All right. Any other questions? Anything in general before we kick off today? What are you guys going over in your main class? What's the topic of the day?
We cover Selenium now.
Okay, so still on Selenium.
Yeah, I think it's 2 more weeks.
Okay. How's that going?
Cool. Pretty cool.
It is really
it's
cool.
Like a magic.
It is. The beauty of automation, right?
Yeah.
Yep. Awesome. Okay. All right. So today we're going to continue covering. So we're not going to algorithms. We will continue covering on Thursday. Today we're going to continue covering some of the good coding practices. I want to give you a at least an introduction into the software patterns. So I don't know if any of you heard about the patterns, what they are, but as you're starting your career in computer science, whether it's engineer or QA engineer, you should be at least be aware of what the patterns are. Have you guys gone through any of the patterns in your main class? I guess not, right?
No.
I didn't think so. So we will not go into a huge level of details with the patterns, but at least I want you to be aware of what those are. And just kind of have that. If you ever come across that, you will know what's being discussed. And then in general, as you are going through your career and you're learning more, whichever path you take, you will do some more research on your own about the patterns and employ them in your, to become a better developer. So that's just really needed for your own vocabulary. And then we will kick off another project. If you remember, we did the a couple projects and small things in the past. We did the zoo program where you practice inheritance and abstract classes interfaces. Then we did the shopping cart example in the beginning of the class. We kind of did a shopping cart class. So we're going to do another project. We're going to kick off, and again, it's going to be something we will do you will do on your own time, and then we will review in class and provide feedback and just kind of finish that up. It's another practice, so you keep getting feedback on your code quality, code organization, that type of stuff. So just kind of firming up all of the theory that we are going over in this class by actually writing, a class that does things that you will do and that you could do in real life. So, okay. All right, so let's just start off with the patterns. Let me bring up the slides. Second. All right. So the design patterns. So design patterns are really very similar to what we talked about. Remember solid principles that we discussed way before, and I'm not going to scroll all the way there because it was a lot. But do you remember the solid principles we talked about? Some of the things in kind of single responsibility. The class function should generally do kind of one thing. You have a single purpose. We talked about it. Few of those principles, injection, dependency injection, where we kind of pass the dependency through interface into the class, and we practice that. And it's really solid principles and design patterns are kind of related. They all talk about how to design good high quality software that's extensible, maintainable, can easily be changed, and it doesn't need to be rewritten every 6 months, that type of stuff. So design pattern is kind of the similar thing. So it's really a set of solutions for common problems. As you're writing code, you're going to be doing things that have been done before, obviously, right? You're not, chances are you're not going to be creating something that's never been solved before. Maybe unless you work for some super innovative company where you're pushing the boundaries of science, computer science, and that type of stuff. But not all of us are lucky to work at those places. But I sure hope you get to solve some innovative problem. But most of the problems we solve have been solved, and there's been already patterns or ways that's been recorded to solve those problems. So and the reason for that is there's been types of things that we do in code, how we create objects, how we create dependencies, all of that stuff that's already been solved, and there are good ways of doing that, and you should know those ways. It's kind of like if you work in architecture, there are ways to build the house, right? Architects don't really have to always figure out, okay, how do I make sure that the house stands and doesn't fall from earthquakes or winds and that type of stuff. There's already ways that they can apply, and we'll solve those problems. So we don't really depend on those architects for our lives. We depend on wisdoms of other that came before it. So same thing here, although in the software it's not as critical, obviously, as an architecture of houses and buildings and bridges, but it's still smart engineers, which all of you are. want to learn on others' experiences rather than make your own mistakes. So this is what the design patterns help you do. So and they help you with kind of writing better code without you having to figure out, okay, how do I do that? You just apply some way that has been done before. So like I said, I'm not gonna go a lot. I think it's for you guys. It's too early to just get really into these things. So I'll cover it so that you know what these are, and at some point in your career you will come across those, or you will just be like, hey, Igor mentioned this thing. Maybe this is a time where I can use it, or let me go and Google something or something like that. So there are different types of design patterns or types of these canned or prepared, I guess, solutions, right? So creational is a number one, and creational is how do we initialize our object? Best ways to initialize our objects. So what do I mean by initializing an object? Create an object, right? You have a class, and then you create an object of that class. So you call a new constructor, and then you create an object, right? So we already when we were talking about the solid principles, we already said that usually, objects shouldn't create so decoupling, right? We don't want to, in class A, we don't want to create a object of concrete class B, because then these classes depend on each other. If constructor for class B changes in any way, you have to go and change class A. We already talked about the way to actually, if class A needs a object of class B, inserting that as in a constructor of class A or something like that through an interface, for example. So we already kind of started covering better ways of writing code, so classes don't create other classes. So creational is a lot more in that area. So one part of creational pattern, for example, is a factory pattern, and you probably going to hear about that pattern a lot. And I think we already kind of saw that in one of the exercises we did. Somebody in the class, I don't remember who, actually had a method that based on input, creating an object, right? In that game that we're practicing, the zoo game, I believe that was kind of a switch statement or something like that. And the method was creating an object based on some argument. So that's really a that goes into the factory method or factory pattern, basically. As an example, there's just having one method or one class creating types of object based on some arguments. So, for example, that, we kind of went through based on what the user wants to be in that game that we created, right? They put an argument, what was it, like some type of animal, having some method or some class actually just create that particular object. So this way you only have one method that takes care of creating an object. So think of it as a factory, right? The factory just takes some input, widgets, material, and provides an output. In our case, it's objects. So then everything else in your application just relies on that factory to create objects. So again, that's probably as far as I'm going to take it, so you don't get too bogged down in the details. But that's an example of creational pattern. So how creational, how do you create objects? And there are other ones, and we will go through some other ones in kind of simple detail as well. So Then there are structural. So as you may know, you have a bunch of things that you do in your classes, right? And you have objects that are combined with other objects to form entities, to form functionalities. So maybe, classes rely on other classes, and they have maybe instance variable of other classes, that type of stuff. So basically it's a structure. So how these objects interact to create functionalities, that's really the whole thing about structural design patterns. So I'll show you a little bit more on that. And the last one is behavioral. So how do objects communicate with each other, how they act? So communications between objects of different classes, best practices around that is what behavioral set of design patterns cover. So that's really it. 3 really different things, because that's really covers everything you do in in your coding. You create objects, and that's where creational design patterns come in play, give you the best practices there. You structure objects to to create sets of functionality, and that's structural design patterns. And then objects obviously communicate with other objects, and that's behavioral. Okay, so a little bit for each one. So quick look. So I already mentioned factory, right? So factory is basically designed to abstract or isolate creation of objects, so other classes don't have to create objects, and they rely on the factory. There's builder, prototype, and singleton. You guys maybe heard of singleton pattern? Nobody? Ugh. All right, so singleton is basically very popular, and you should know that because singleton is all about creating a single instance of some object. So in your application, right, you have basically a bunch of users, right? And each user request will probably create a new object, right? So as you engage with your application, user will instance, of the application will create its own object. So singleton deals with a case when you cannot have multiple instances of an object. And that's useful when you should, all the users' sessions should share one object. So there are shared resources. So for example, if you have a resource representing some hardware like printer, right? Like interface to a printer or interface to something that's like single resource. And you need to have like all the users communicate with that instance. It probably won't make sense for you to let users create multiple instances of a printer interface, right? Because there's only one physical printer. Those will collide, and you're going to get a mess, right? Because there's only one physical printer. So here, that's an example of where you would apply a singleton pattern, where you basically are going to create an object that has a private constructor. There are a couple of ways to create a singleton pattern. There's a private constructors, there's some instance methods, but there are things where you basically prevent every user from creating its own instance of an object, so that every user that interacts with your application, right, will always use the same instance of an object. That way, you know that you can manage all the actions that all the users take, right? So if they want to, for example, interact with a printer and queue things into the printer, you have that's some kind of a queue where you can really manage all the requests, and you don't have 100 different queues that have no idea of each other. That's what you would get with creating an object for each user. So does that make sense? Any questions on that? Like singleton is a big thing there. So you can Google singleton pattern specifically, and basically you can you can look at Wikipedia or any other, but it basically restricts initialization of a class to single instance, right? So you can get more information, and you can get more information about how to do this, right? So how you actually do this, because that stuff does come up on interviews. So for example, here they show you that you have a class, let's say they name it singleton, but it could be your printer class, right? So what you're gonna do here is you're gonna create a private constructor, right? So private constructor means that nobody can create an object of this by saying singleton, my singleton equals new singleton, or printer, my printer equals new printer. Nobody can create a new instance. Basically, what you do here in this class, you already are creating a single instance here in this line by creating the static instance, right? Static final instance of this class. So you're basically creating, this is the only instance that's going to be available to anybody that interacts with your class. Now you already have that instance. Nobody can create new instances by you making the constructors. But if anybody needs to find that instance, because there are going to be methods here, right? Obviously, this singleton class or printer class or whatever shared thing you want to do will have methods. In order to communicate with the methods, you provide a static instance, get instance, right? So you basically controlling access to this variable, and you return that instance, right? That's it. That's the only instance you have. So then you basically guaranteeing that everything, all the users are going to be interacting with that in a single instance of this class. And you can obviously use this to your advantage to control shared resources. So that's, I believe this is a C# implementation, or well, this is C# implementation, and I'm sure there is a Java somewhere for you guys. There it is. Right. So there is a actual example there, right, for like a coin class that they using singleton pattern on. So as you can see, very similar get instance, and then as you can see that everything goes through the same kind of way to interact with that same class. So just an example of the type of creational pattern that exists, and what singleton is. Somebody asks you what singleton is on the interview or something like that, then hey, it's a type of a pattern to restrict creation of new objects of a class, right? And like I said, feel free to look more. Same with factory pattern. Tons of examples are available in there, and Wikipedia or tons of other websites give huge amount of information on any of these things. So and bunch of examples here. For example, we can look at the factory pattern here, and scrolling on to Java. Not Java, just Python, PHP. Oh, there's Java. As you can see, for example, the maze game, right? Has a kind of the method to make the rooms for what I guess a maze game, but this is kind of the method to create a room and do some stuff with the rooms, and I assume that they have some type of functionality to other classes call this method to make a room, right? So basically abstract this functionality to make some type of an object. So but you can do more research when you're when you need to, right? It's not something you're going to be jumping in right away, for things, usually, especially on the QA side. But, good to know. So look at the slides and do some more research. Again, factory and singleton, I think, are the most used patterns out there. So, that's why I wanted to mention singleton a little bit more. Okay. So that's all about object creation. When we create objects, how do we do it? How do we create, different objects? How do we create like a single object? Structural patterns is all about really how objects, are, structured, and a couple of noticeable things there. As you can see, there are like 7 patterns there. Adapter, decorator, proxy, they're very, very, very similar in what they do. So as you can see, these things are kind of proxies, adapters, and that type of stuff. They are they mask something. So for example, if you have a legacy system, and the legacy system, old system, that has bunch of different classes and interfaces to communicate, and sometimes it's really, really complex or outdated, and other systems can really easily connect to a system. So that's where things like adapter or proxy patterns are used, where you would basically create a set of interfaces that you will abstract and simplify all of the functionality. You have to deal with all the complexity of those legacy systems, but you would provide kind of an adapter to other systems, right? Like think of it as an adapter where you have, if you go to Europe, you take an adapter for your electrical outlet, right? Electrical outlet is one type of a system. You're in Europe, right? What is it, 220 volts of electricity or something like that, if I'm not mistaken. So they have one system. In America, our electrical devices use 120 volts, right? Again, if I'm not mistaken. When you take your laptop to Europe, you need to, you don't want to plug it into 200 volts of electricity, because you're gonna either fry your device or cause some kind of electrical outage. So you get an adapter. Adapter is basically transforms electricity between your device and the electrical grid of the country you're visiting. So that's the same thing here. Adapter, proxy kind of have the same type of functionality. They take one system and adapt it to needs of another system. So, again, you can learn a lot more about these things, but I just want you to have some idea, right? So, if you see something like this, you'll already kind of have heard it here, and you're not gonna be super surprised, or if it comes up in the interviews, at least it's better to say that, hey, I'm aware of them. That means that you maybe haven't dealt with them because you don't really yet have experience designing things, and I don't want to confuse you with that yet. These usually have to do with pretty complex systems, sometimes legacy systems, different types of systems that need to communicate. So outside of the scope of this class, for sure. But it's good that you already kind of know your next things that you may want to learn. Okay. So that's really structural patterns. And then we have behavioral patterns. As you can see, tons of things here. Also, how objects behave, interacts with each other, rather than their structure. Strategy pattern, one to note here is basically you creating a strategy for, for objects, kind of a template type of a pattern here. So very common. You create basically, if you want to have different objects that have similar kind of function, you can create kind of a strategy pattern so that they and abstract methods and that type of stuff to implement the strategy pattern, and then those objects basically use that strategy. So that's one. Iterator, you've used this when you do the looping. So that's really iterator pattern is how you go through iterations, right? So that's all of those loops, everything, basically implements the iterator pattern. It's really how you iterate through a collection. So it doesn't just magically happens. There is a pattern that's Java and other languages use to kind of help you. There's a collection. If there is a data structure, that they implement that pattern so that there is a ability to use a kind of a for loop or while loop, that type of stuff. So that's basically kind of the high level overview of different types of patterns out there. So usually, like I said, architects, senior developers, they deal with this stuff. When you're designing large scale systems, you're certainly going to need to know these. So if you when you get to that level, when you're learning, don't ever stop learning, right? So that's where you kind of you're gonna revisit this thing. And there is a book called Gang of Four. Four patterns. So this is a very popular book, which is written by a few really, let's see, really talented developers there. So there's four of them, so that's why they basically they call it Gang of Four. But the book is really about design patterns, so it's really about elements of reusable object-oriented software. So when you want to write reusable software, this is kind of the building block of that. So as you can see, we kind of, there's way more than I showed you, especially in the behavioral patterns. I think, but it's a really worthy read for when you get to that next step. So tons of stuff there that you can learn. So I highly suggest that go to your library, look at this book at some point, and I think that's it's going to be really, really useful for you to kind of understand more about coding. Not necessarily even about these patterns, but it'll teach you more about coding and that type of stuff. All right, questions. Does that make sense? Good.
It's very complicated. I think.
It is not easy.
Mm-hmm.
It isn't. It's not. Some of these are kind of frustrating because that's why I don't want to kind of get into a lot of details here because some of these I even never used, and I tried, and it's sometimes just like and that's some of them I use more often than others, but like singleton is really, you need to know singleton. They'll ask that for interview in any job. That's a given. Factory is another one. Proxy, adapter, those are things that you guys should probably, but some of them are more specific, I want to say, right? Specific to some type of a problem. So it's really hard to keep all of them in mind and just be like, okay, well, this problem fits this memento pattern. It's not that easy. So all I can say, just at some point, read the book, keep this in mind. At least that information is there with you. Whether you're going to use that or not is something that all will depend on where you take your job and how complex your environment is going to be, and whether you do software engineering in the future, stay in the QA space. Even if you stay in the QA space, if you're writing some automation code, you may be using some of these patterns. So better at least to be aware of them. Okay.
Igor, can you sorry, maybe it's a stupid question. Can you give us example where can we use the singleton in real job? Not with the dogs and cats example, but real example.
Let's take a look. Maybe better to Google. So let's see what global configuration, log manager. Okay, there is a so yeah, that's a good one. So when you're writing some type of a log manager because logging accesses a single resource, right? So singleton pattern is all about managing a single, usually a physical resource, right? So that's where you wanna. So anything that manages like anything related to like a file would be a singleton pattern. There's the log manager right there example. So logging, right? If you're writing your own custom logging, because if you're going to use a log4j or other frameworks for Java, the implementation is going to already use a singleton pattern because it interacts with one file. But if you're writing your own logging framework, which some companies do, they don't rely on, they need to customize logging, then that's a singleton pattern. What else?
Igor?
Yeah.
In our Selenium class, we have a properties reader class, which basically just has a static initializer and just one method which returns some sort of properties.
Yeah.
Would that be considered a singleton?
Possibly, I will have to look at it, but possibly. What is it dealing with? What is it doing in that class?
Well, basically, we have just one properties file.
Oh, yeah.
which
Yep.
contains like browser and stuff. So,
Yep.
and all it does, it just reads from it.
Yep.
That's so, okay.
That's very simple. You know, here we're all just when I was looking at it, right? So this, I think here somewhere it said that this is usually used for configuration file management. So properties configuration file. It's a good, you know, good candidate for this pattern. Yeah. Yeah, somewhere I thought that I said the configuration. Yeah, for global configuration, which is probably what your program is doing, some kind of configuration or settings or something like this. Yeah, but anything really that has to deal with a single, usually physical instance that you need to manage access to, you know, and you need to have some type of control over how that physical instance is managed. Because, for example, if you are like using a logger, then if you're creating you know, bunch of instances for every user in the application, then you are not going to, you know, you're going to be trying to write into the same file from multiple instances, you know, and that's not going to work, right? So that's why you have kind of, you know, single instance, so that there's just one you know, write. So same with other type of things. All right. Any other questions on this? Yeah, see, you know, it's basically a bunch of things trying to access kind of one resource. That's really all about singleton. And this one, it even has some funny pictures. Yeah, like I said, feel free to do some research when you get interested of that. But let's see if there's any other. This just one, so nothing says I'm gonna replace it. The cache things when you communicate with cache. Okay, so that's another one. So communicating with cache in your application, cache of whether it's a server or a browser cache, there's only one, right? So you want to control access to that. So, you know, cache would probably interface for cache would use a singleton instance. So cool. All right, so enough talking. Let's get to some exercises. So what I wanted to do is let's get this. I have where is it? Let's see. Okay, so I wanted to start this project. So we're going to be doing more of a design here, and you know, as we're designing, maybe we will look at applicability of some of the patterns there, that type of stuff, or not. Maybe it'll be simple enough. But in this exercise, I want you to start thinking about a vending machine. So imagine you are doing a kind of a digital vending machine, writing a software that will, you know, be an interface for the vending machine. So, you know, this will get you thinking in object-oriented way. So I encourage you to make everything as an object. That's kind of the object-oriented way. Everything is an object, right? So, for example, you know, the actual coins, the products, the vending machine, everything should be an object and object-oriented programming, right? So because objects have properties, and it's just easier for us to think about programs as objects because it just comes naturally. Although there are arguments that object-oriented programming isn't always the best thing, and that's totally true. It's just one of the tools, because they're functional programming. There's a bunch of other things that you can learn about which fits better to certain problems. But you're probably going to be dealing a lot with stuff that fits well for object orientation. So this vending machine would do following things. So you'll accept the following types of coins. So obviously it's outdated vending machine because it accepts a penny, but whatever. So 1, 5, 10, 25 cents, penny, nickel, dime, and quarter. So it's a retro vending machine from like the 70s. I don't think current vending machine accept pennies, if I'm not mistaken, or they probably accept only like dollars and up. But for this exercise, we'll just have it accept this type of input. Allow the user to select out of 3 products. So you're gonna have Coke, Pepsi, and a generic soda for the prices that are provided here: 25, 35, 45 cents. Allow user to take refund by canceling requests. So if they change their mind, the refund is initiated, where you give them back the money that they inputted. Return selected product if they decided to go with a transaction, and remaining change if needed. So if they put in more money than it's worth, then give them the change if if they are due change. And then allow reset operation for vending machine supplier. So basically you want to have some kind of a functionality where you restock the machine. So you can get creative, but for example, you can start with, let's say, a 10 of each product, and then some type of functionality where the products will be sold out, and then you allow for the reset, which is basically restocking feature. So bonus for this would be create more products, right? You can create, this is just an example here, you can create different types of products. You can create chips, you can create Snickers bars, anything that you want. So think about the different types of the products you want to put in this machine, and with ability to restock each one of them, and maybe even some type of a message when the product is running low. So this would be a good a way for you to use your testing skills and basically keep purchasing a product, and hopefully get a message that the product is running out. Or maybe you can even get creative and say, before it runs out, like have some kind of threshold, maybe like before there is less than 10 products, send some kind of a call to provide some kind of a message or something like that. So, but in general, I want you to start thinking about that kind of the vending machine class, different methods, where you put the methods, the products, how you represent the products, how you present all the transactions, and then manage the all the interactions of the user and the vending machines and the products. One thing that's not put here is you need to keep track of money in the machine. I didn't spell that out, but I should. You need to be able to, keep track of the money in the machine and have inventory of, coins. So basically, you're gonna have certain number of coins in the machine, so you can give change, and then you're gonna keep track of the money, so that when somebody buys that, buys the merchandise, you keep adding to that, money in there. So. All right, so questions. How would you get started on this? What would you, without writing code, how would you design the classes here? So maybe we can do some brainstorming, or storm through questions here before we kind of go. I'll let you spend time on your own. So how would you design? What type of classes do you see? What do you guys think?
A vending machine that has actions such as
okay, so
provide the product.
Vending machine. So that's a class has, okay. What do we think it will do again?
It has some actions
Okay.
like providing the product or taking money and then refunding money.
Provide product. Okay. Return money. Okay. All right. Okay. What are the properties that we want to put on the vending machine? What is it? What should it have? So that these are the methods. What types of properties? What do we want to keep?
The count of the money it has. Probably some sort of a map with a coin and how many coins it has.
Hey, maps, I like that. So, so I guess balance, right? Some kind of a balance tracks number of each coin, overall sum, I guess, right? We want to be able to know whether the right. So, okay. What else? What are we missing in the vending machine? How do we restock it? Maybe. How do we do that? So remember, we talked about we need to be able to restock it or reset operation, right? So we need to have, so add product, right? So you wanna, the vending machine by design, like remember, imagine you bought a vending machine from a company, right? So vending machine doesn't come with Coke, right? And you need to have a method to stock it, right? Restock it with a product. So that's the add product at the minimum, right? Cool. How do you guys want to manage these coins and the products? What's a product? What do you want to have for product? You want it to have a separate class, or how do you want to do that? So for example, provide product here or add product, what type of arguments do you want to provide to this?
I think we need separate classes for Coke, for Pepsi, for
Yeah.
none.
And product will be like a dependency injection, some sort of a like interface or abstract class.
Maybe. Yeah, so think of both cases, right? So if you have a product for also, I'm sorry, a class, if you have a class for each type of product. So if you want to add products, right? So you would just create another class for that to represent, that type of a product. So one thing, it's a feasible thing, right? But so I'm kind of combining what I heard. You probably want to have some type of interface, right? Because you don't want these classes to take, for example, if you have, provide product or add product, here you want to probably use some kind of interface to pass something in, right? Because if you have your vending machine, for example, think about it this way, right? You're programming a real world vending machine. So as you know, the vending machines, they have software running, right? It's not mechanical. They take credit cards, they take cash, and they have some kind of software inside it. It's embedded software, but it's still software. Just because there is no computer that you see, it doesn't mean that there is no software. So that's what we're writing. So the vending machines usually have a kind of a ability to add multiple products, right? So you want to design a vending machine where you sell it, and you say, my software on this vending machine allows you to, if you feel like selling chips, if chips are not selling, maybe you can sell like carrots, right? Or you can sell, anything that's healthy, and kind of change your machine into a healthy vending machine. So I encourage you to think that way. So this way, you don't have to reprogram it. All you need to do is basically, set up a different type of product. So the operator would connect to your vending machine, and you'd give them an interface to set up a product. And the product would have certain common properties, right? So maybe a product interface will have, what would you want your operator to input? Let's say product name, right? Maybe description. So Coke, carrots, potato chips, something like that, right? So it can be something. You probably want maybe some kind of ID. I don't know. I don't know if it's matters or not. Maybe the name would be unique. You want the price, right? Is there anything else you guys can think of? Name, price. You need to think of a new product. What else would they add in there? I guess that's it, right? Maybe you want to have some kind of think about, let's say, minimum quantity. So you want to have some kind of minimum quantity, and then as the threshold goes down, that the operator will get some kind of a message. So maybe you have a fancy vending machine that says, you don't have to come to check every week or every day, or scared that your vending machine ran out. The vending machine will use an API and send you a text message, So you just tell us how many, what's the lowest quantity of product you want. And if it goes under, we will send you a text message and you come and you upload your product. Pretty cool, right? Good selling point for your vending machine. So then you basically, so every product, every new product can be configured, right? And what this means, what the challenges for you as engineers is to make sure that the code for the vending machine should not change, right? So code for vending machine should not change. So, you don't want whoever bought your vending machine, they say, okay, I am trying to input this product and, can you make a software change and upload it into your vending machine? You don't want them to call you every time they have a new product. So you probably want to, as your vending machine is dealing with these products, right? You want to make sure that these are configurable and your vending machine is dealing with a generic thing, and generic are represented using interfaces usually, right? So when you take thing, you take some kind of iProduct, right? And here, same thing, iProduct. So then you don't need to deal, and inside of these methods, you should look into interact with properties of the iProduct. This way, no matter what the product is, all you need to do is, you're basically going to transact with it. Each product has a price, has a product name, and some type of other identifiers you may want to put in there. Does this make sense? So for the money, it could be, it's probably could be a little simpler. The money doesn't change, as much as products. So for the money, you could probably have some type of a class that's, or, I don't know, you can think about, money. So to represent maybe how the user inserts the money. It could be just, it could be just an integer. I'm sorry, a decimal, or some kind of a collection, right? We went through collections of something so like a hash, right? Not collections, okay, hash. So depending on where, as you have your money in the machine, then you probably want to have the number of each coins, right? So maybe some kind of a hash will do. That's why we covered hashes, where, because you want to know whether you have enough, 10 cents. Otherwise, how would you know whether you can give a change in 10 cents? So you'd want to have some kind of a hash where you're gonna represent that, right? And possibly even alert the operator that you just don't have any more pennies left or something like that. Because last thing you want is somebody is giving you money and then you tell them you don't have change. That's a crappy vending machine, right? They're probably, the operator of the vending machine is gonna be like, why didn't you alert me or something like that? Or, if in the worst case scenario, if you don't have change, you should probably return the money to the user, right? And say a transaction cannot be happening, but you shouldn't just fail, eat their money. So. Okay. So it goes here. So what do you guys think? Is it doable? Any other questions on this? Hopefully not too challenging, or let me know if you feel like it's just too much, or
Probably take a few hours.
oh yeah, I assume it's going to take more than that. Yeah, it's probably going to take more than that. So, just be creative on how you want to test it, right? The console stuff is fine. Maybe you can, get creative on the testing, right? Obviously, I'm not asking you to create kind of a graphical user interface. I don't think you guys covered, the interface design, all of that stuff. But, just maybe how you guys did with that zoo game where, you had, user put in input. So maybe you can give them selection. Again, it doesn't have to be many products, right? So you can design for multiple products, but put in like a couple products there, whatever you want. These are samples. They're boring. It's just seems like it's a soda machine, but whatever. You can do maybe soda, chips, and chocolate or something like that. And then maybe put that in the console app. Just here are the products, press 1 for soda, 2 for chips, 3 for whatever, and then when they do that, you kind of take their money. Or it can be simpler where they press like 1 and then comma, and then they input the how much they're putting in, right? So if soda is like 50 cents, they put in $1, so they put 1 for soda, and then they put in like $1, then you'd get the well, I don't even have $1 quarter, so maybe soda, Pepsi is 35 cents, they put 2 quarters. So, they put 50 cents, then, you'd give them, the product, and then the change. Or if they put 35, then you just give them the product. So that type of stuff. Just have fun with kind of how you'd represent it. That's all learning for you. Make it fun, interface via console. So. But we'll go through this exercise on our Tuesdays. So we'll kind of have 2 of these projects going for next week or so, as you kind of getting hopefully experience with this, and I'll be giving feedback, and we'll start with this next Tuesday, and then obviously Thursday, as I mentioned at the beginning of the class, look at the binary search. We want to practice that. Cool. I will put this into the Slack, both of the things here. So I'll do that right now. And I'll post the actual design practice thing here, as well as what we just discussed, where we can outline some of the possibilities. But feel free to roll out your own. This isn't this is not to put you in some kind of single way of doing that stuff. So let me do the other one. So I'm just putting that in Slack. And, All right, so if no questions, then I'll let you have maybe 15 minutes, kind of organize your thoughts and start planning for that. And I will see you all on Thursday.
Thank you.
All right, bye.
Thank you.